Okay, so it's time to start finally. Okay, so on unfortunate day, September 26, 1954, a tragedy struck the Japan. Because there has been a typhoon, which unfortunately led into the death of 1,400 people, which lost their life when they were attempting to cross the Tsugaru Strait. This strait is between the two biggest Japanese islands. And it's a very often road which people are taking to Japan. It used to be the biggest domestic travel road in the world. So many people are actually moving in that direction. And that was the reason why the country made a very bold decision, and they decided that they will build the longest undersea tunnel in the world. And they really upholded that, because after the 34 years of very hard labor, because of course it was extremely complicated and their work must be done in an environment which is full of the earthquakes and things like that. They finally made it in the year 1988, and it was a huge event, and it's one of the biggest engineering marvels. It was extremely ambitious thing which should change everything connected with transport in Japan. The biggest thing. And in that way, it's like a WebAssembly. So today's topic is the state of WebAssembly. What does future hold for browser-based applications? My name is Bohuslav Šimek. I work as a lead developer at PeoplePass, but I'm also a PhD student. My main research focus is effective execution of scripting languages, such as, for example, PHP or JavaScript, but there's also some Ruby, Python, things like that. I'm a contributor to a few PHP magazines. My last article was deep dive into the MySQL protocol, in which we kind of write that protocol from scratch without any existing extension. And I'm a proponent of Atwood law. And Atwood law states that any application that can be written in JavaScript will eventually be written in JavaScript. Yeah, this used to be kind of a joke, but well, nowadays the reality kind of kicks in. Oh, okay, great. Okay, so the question is, if the JavaScript does not suffice, because nowadays we know that the web is the ideal distribution platform. So if we want to actually distribute any software to our customers, we usually use the web for that. But there can be situations in which JavaScript does not suffice. After all, the original reason for JavaScript was to just create a simple web animation, such as these falling leaves. But this has been a problem for a very long time. And so some possible solutions to that problem. So since late 90s, a few technologies emerged. Technologies such as ActiveX, Java applets, or Flash. We will start with ActiveX. Well, this was a typical Microsoft product of early 90s. So it was proprietary. It works only in Internet Explorer, only on Windows. But probably the biggest issue, and I dare to say a sin, was that there was no security model. And it was a huge issue in the case of ActiveX, because ActiveX allows you to run binary without any sandboxing or security model. So basically, the web page downloads some binary and then run it. You know, I always used to think that this was some artifact from the early stage of the web when everybody was trusting everybody, you know. But the reality is a little bit harsh in this case. Virtually same thing I can also say about the Java, and especially the Java applets, with one biggest difference. Now your problems are actually multi-platform. Because Java has, at least Java applet, has some security model, but this still was kind of flawed. And there was also another issue. It was extremely slow, especially on the beginning, you know. And when the community back then realized that the Java is slow, it kind of stick to Java. And even today, when Java is no longer slow, it can be actually one of the fastest languages, still people think, yeah, it's a slow Java. And there's also one very interesting thing from my personal experience. Back then, you actually need to download the Java virtual environment to run anything on your web page. And that was a very huge thing, around 6 megabytes, which was a big thing 25 years ago. So I virtually find out a page which was using the Java applet. Then I realized that I need to wait 6 hours till I download that environment. Then I run it, and it was extremely slow. Last but not least is a Flash. Flash was probably the best of them, yeah, which is a strange statement. But yeah, if I need to choose any of these technologies, Flash was actually kind of good. Flash was killed by Steve Jobs. That was the first nail into coffin because the iPhone simply doesn't support it. And very often, Flash has been overcome by the HTML5 together with JavaScript. I also forget to mention one very important thing. All of these technologies, they look kind of different on the web page. Usually, very quickly find out that there is something different. That there is a Java applet which look like from the end of the 90s and things like that. So they were never so seamlessly integrated. Of course, all of these things were based on the plugin system in our web browsers. Without the plugin system, they simply won't work. Unfortunately, this has been removed a few years ago because it actually brings more complication than it solves real problems. And everything has been replaced by our duo of HTML5 and JavaScript. OK, so this was a short history intro. And it kind of shows us what we actually need, what we are expecting. So we are kind of expecting, in the case of the web, security, that it won't attack my computer, that the integration with the rest of the web will be seamless, and that the support will be out of the box. No need to download anything. Because it usually feels like one-time download, but you also need to kind of get regular updates like that. And especially Flash has a lot of the problems. And last but not least is efficiency. Because without efficiency, we cannot build a very complex applications. So let's focus on the efficiency. Because very quickly, people realized that JavaScript really does not suffice. And the first attempt to solve this was technology from the Mozilla called asm.js. And that was a strict subset of JavaScript. There was no garbage collector, no OOP. And you actually never write this by hand. This was always done by the compiler. In this case, the compiler used to be called, well, it still actually exists, but it no longer emits asm.js. But it was called mscripten. It simply takes your C code and transform it into the JavaScript. The reason why it was so slow was that it supports only basic operations. And if you have basic operations, you are able to actually execute them extremely quickly. So if your programming language can basically just subtract, add numbers, it will be extremely fast. So that subset of JavaScript was then very easily optimized even further. And WebAssembly was kind of another attempt and was built upon these ideas. But now, it's not only about the Mozilla, but it's more a collaborative effort. So one of the biggest achievements of WebAssembly, from my point of view, is that finally all web browser vendors sit together and came out with one solution. Solution which was out of the box working in all of these browsers. So we finally have WebAssembly. And of course, there is no need to write JavaScript anymore. Yeah. Oh, wait. It was more meant as a target for compilers. So again, you never need to write WebAssembly by hand. Just in the situations in which you simply wanna try it because it seems like a fun. Trust me, it is not. But it was favoring from beginning the specific set of programming languages. Languages which were static, not so dynamic, not scripting languages. And in this case, we are talking about C, C++, Rust, these type of the languages. And to be frank, from the beginning, everybody was saying, yeah, this shouldn't replace the JavaScript. This will be just another tool in your tool set. Yeah, that's kind of a fair point. But on the other side, the rest of the web, the promises there were also completely different. The DOM, for example, was never meant for creating a complex web applications, but we are still doing that. And whenever you gave web developers some technology, trust me, they will find some twisted way how to use it. So it kind of makes sense that people trying to do something similar with WebAssembly. But back to the WebAssembly. The implementation itself is extremely simple. So there were no features like in the Java virtual environment or in the .NET. And also the native access to DOM was kind of missing. So whenever you actually want to change anything from WebAssembly, you need to rewrite this through the JavaScript. Yeah, which there is still a performance penalty. And also there was just a few data types, which is kind of interesting stuff. It's a little bit low level, but it a little bit shed the light into a few things. So there were no objects. There were no strings, no arrays. And especially strings are kind of a problem. Because to create a good string abstraction over the arrays, you now need to tackle with things such as UTF, and especially UTF-16, so a little bit complicated thing. So, and you basically just have a integer and float data type, then you have some references later and some, I will forget it, but it was for metrics. So it was very low level specific thing. So we actually need to do everything from scratch, and that's kind of explain why the WebAssembly usually favors some existing compilers or runtimes. Because they already do this stuff, so they will no longer do it for the regular assembly, they will choose just the WebAssembly. Her point. Of course, as the initial machine was so simple, then came a few extensions. Extensions such as SIMD, oh my gosh, always struggle with proper pronunciation of that. Stack switching, branch hitting, and garbage collector. And well, all of these things are pretty much low level. They're for somebody who is creating the compilers. Because I can, for example, tell you that the first thing, which I cannot properly pronounce it, speed up the operation with matrices. Stack switching can be used for implementing the coroutines and to async away. And I am showing you this because I just want to point out what they were trying to achieve with WebAssembly. But then came a very interesting thing. The next batch of extensions start to be more high level. So we now have a support for exceptions. We have two versions of that. One is already deprecated because they made a little bit mistake. Well, it can happen, but unfortunately, browser vendors need to support this for upcoming decade. Bad for them. There is a support for threads, which is also kind of good. You usually need some form of communication with the browser. And then you start to have something which will more communicate with JavaScript, such as string build-ins, promise integrations. So we now kind of see that they're switching more to a high-level thing. Interesting strategy. But there are still a few things which will never happen. The support for OP won't be there. There won't be direct DOM access. But people are still trying, so maybe there is still some way. And also there will be any optional types. No support for that. And this has one very interesting impact, because it means that WebAssembly is more suitable for compiling the PHP interpreter into WebAssembly than to compile a pure PHP script into WebAssembly. Yeah, it's a little bit inception level. So whenever you actually want to use assembly for running the PHP, you need to compile the PHP interpreter, then put that PHP code into the web, into this interpreter, and run it. And then you kind of have it. So just another layer of indirection. So the best metaphor which I was able to find out for this is this. Or we can, it can be like a matroshka, for example, so it's still an inception level thing. So you basically have a virtual machine of WebAssembly. Inside that, you have a virtual machine of PHP, and then you have your own code. But of course, this is not PHP exclusive. Same thing can be said about the Python, Lua, Ruby, things like that. And it's the price of dynamicity of these languages and also of the complex runtime library. And if you really want to try the PHP in the WebAssembly, it's kind of easy. There is already a package for that. You just need to virtually include one thing, and then you can do this magic. Just call the run function, give it a piece of PHP code, and well, it's working. And of course, I prepare a few demos. I won't show it to you because probably the most interesting thing about these demos are that I didn't write any piece of the code. I vibe coded all of them. and it worked on the first try, which was kind of surprising for me, because inside these demos, there is the way how to communicate directly with the browser. And I'm so surprised that ChatGPT was actually able to know how to properly use it. A little bit scary. So definitely there is a way how to do it and how to work with the DOM. But if you want something a little more practical, you may be, as a PHP developers, already encounter the PHP which is running in WebAssembly. Because a lot of the sandboxes for PHP are actually built that way. That's somebody compile the PHP into the WebAssembly and then allow you to run the things. And what is rather new thing is also that you can now run the examples of PHP code in the PHP documentation. This is a brand new thing. Now it's, of course, time to address the elephant in the room, because at PHP conference, there is always elephant in the room. And that's the speed. Because when I compare the speed of PHP on my local environment, basically the same benchmark, with the code which was running in WebAssembly, I realized that it's 80 times slower. Yeah, it was just a benchmark. So, of course, it does not show you a full picture. But yeah, there is definitely a price in the virtual machine or virtual machine approach. Okay, and it's time to go back to Japan. We will actually go back to the second tunnel, and we will see how actually second tunnel impact to Japan. We'll start with something a little bit personal, because on August 7, 2014, I was in town called Aomori, which was just next to the Korean Strait. And I need to make a decision, because I don't know what I visit as the next thing in the Japan. And I need to decide if I want to visit the Sapporo, which is the capital city of Hokkaido, the next big island. So I will need to use the Seikan tunnel. Or if I want to go to Nagano, which was on the completely opposite direction, and the distance was twice than to a Sapporo. But funny thing was that it took much more time to actually get into the Sapporo, even with that tunnel, and even when the distance was significantly lower. Because there was one very interesting thing. Even in the year 2014, there was no high-speed railway in the Seikan tunnel. Nobody simply put it there, even if there was a plan for that. And the reason for this was that virtually no passengers were using the Seikan tunnel. Almost everybody was rather using the planes and air travel, because it was faster and it was actually much more cheaper. So yeah, they actually built an engineering marvel, but virtually nobody was using it. And it still costs them money, because you need to do a maintenance for that. So great piece of engineering achievement, but simply nobody's using. I saw a lot of the articles that it's just a ghost tunnel. And personally, when I actually needed to use, I really buy the art ticket for the plane, because it was significantly cheaper. But okay, so back to WebAssembly. So maybe that was just an issue with PHP. So let's try some other technology. For example, the Blazor, which implements the .NET and particularly the C#. And thanks to that, you can build your own frontend now in C#. Nice. It will be run with the help of WebAssembly. Sounds like a good idea. And now it's 4 times slower than vanilla.js. Okay, so there is some price that I'm using some framework. Maybe I can live with that. It's the slowest framework which you can use on the web. By far. It's really the last red column. But, well, there are still the situations in which this can make a sense. Because it's always choose the right tool. And maybe if you don't have a very intensive application and you don't want to struggle with JavaScript, maybe this is the right way. Okay, so I was digging further, and I found out something called AssemblyScript. This is another inception level, because this is a subset of TypeScript, which itself is a subset of JavaScript. The biggest difference of AssemblyScript, if we compare it to TypeScript, is that it does not support some portions of OOP, and it does not support any data type. So you always need to provide the types. So yeah, it's kind of interesting, right? It's a little bit better than we have something which is finally faster than JavaScript, twice. Yeah, it's still kind of interesting. This can be very interesting if you are very into the efficiency of type system, because in this case, the types can help you. And it's kind of shame that a lot of the TypeScript compilers are not able, or runtimes are not able to use that information for the better performance. But now more a PhD student was talking in my case. Okay, so far we have a performance issues, usually connected with the virtual machine over virtual machine approach. There is no direct access to DOM, so you need to kind of go through the JavaScript. So what about some other languages, So I did some stats, and I realized that in the half of the cases, the most common language is C or C++. Then we have a Rust, then our AssemblyScript, and the rest is not so. There is some Golang, and actually no need to care about the rest. So maybe this is really for something like video games. And every time when somebody is trying to do some hacking, they usually port a Doom to the technology. But in WebAssembly, we got better. We have a Doom 3. Yeah. Which sounds nice. Then you realize that it's more than 20 years old game. So it shouldn't surprise me that it's now running in the browser. So I was digging for something a little more, let's say, modern. No offense. I found out some demos only. And then I found one very interesting information. There has been a support for WebAssembly in Unreal Engine 4. And it has been removed from Unreal Engine 5. Yeah, so it sounds like a technology of the future. Yeah, if they remove it from probably the most used AAA game engine. Just one very important information, Unity is working very well in WebAssembly. So it's not only about the Unreal Engine, but you usually want to have the best. Okay, so we will look back into the Japan. Maybe that will offer some answers. And we will again kind of jump into time. Now it will be to 2024, because the Japanese railroad make a huge announcement. And that was that they allow to rise a speed of the trains in the Seikan Tunnel. So instead of 160 kilometers, it will be 260 kilometers. But it will be only during the holiday. This is extremely strange thing. Yeah, but it's still something which you would probably expect from Japan. Something extremely strange. But so it kind of seems that trains can always be fast there, And why they want to change it just during the holiday? It's kind of strange. And then you realize that the Seikan Tunnel is not only used for the passengers, but also for the cargo. And they don't want to allow a faster train because they're afraid that these trains will kind of tip the cargo in the tunnel because, the physics. And another issue is that the Hokkaido is kind of a granary of Japan. So a lot of the plants or cattle are actually rice grown in the Hokkaido. And it's the tunnel which is kind of used for moving this product into the rest of the Japan. So yeah, the main idea behind the tunnel was to move the people, but it mainly now moves the crop, the farmer's product. Okay, so maybe this can also be a way for the WebAssembly. We can kind of pivot it from the web to somewhere else. Yeah, there is always that possibility. There was actually excellent talk about that an hour ago. Because what we have is a universal virtual machine to which we can compile a lot of the code. It's not bind to any specific language. It's not like a Java virtual machine, which is tailored specifically to Java. And there is the support from sandboxing out of the box. And there is also a really good component model on the way. It's a little bit Acroba vibes, but let's try it again. Maybe now it will be better. And there are also some practical use cases now. So for example, Shopify allows you to use the plugins which are written by the end user. And people compile them into WebAssembly, and then it's run on their servers. And actually something similar is also true for the Cloudflare, because they also allow you to run the code compiled in the WebAssembly. And you finally have a proper sandboxing for all of these things. But I really want to have it on the web. Yeah, because I'm that type of the guy who want to twist the things, you know. And to be honest, I don't like JavaScript, but you maybe already find that. So I was tried to put even more energy into find something. I realized that there is a nice framework for the Rust called Leptos. So if you like Rust, it's kind of good for you. The issue is that Rust is, of course, kind of complex. So I don't believe that everybody will now rewrite its frontend in the Rust. It's not like with the rest of the software. Also, it does not reach the speed of vanilla.js, but is at least faster than the other JavaScript frameworks. Okay. And something more practical in the case of the Rust. Actually, the Prime Video rewrite their frontend completely in the Rust. And I know that the first question which you want to ask me now is if this saved the Rings of the Power, the TV show. Unfortunately not, but now you can much quickly switch to another TV show thanks to the Rust. So at least it was a little bit useful, let's say. What is also kind of interesting are the statistics from the Chrome, because according to them, the 4.4, almost 5% of web pages, or their loads actually in Chrome, are using the WebAssembly. And I now hope that this is not for Bitcoin mining or for something illegal. But I still want it as a replacement for the JavaScript. I was thinking, why? JavaScript is not so hard. To a degree, it's similar to PHP, at least more than PHP is similar to Python and things like that. And I realized that maybe the issue is with the ecosystem, that this can kind of play a role. And that I don't like the language-specific thinking, you know, how to do the stuff. And I really want some integration across the stack. And I actually can have a solution as a PHP programmer for that. I can use a Livewire or any other of these frameworks. Or I can try to do some crazy stuff, like, for example, do one-to-one port of JSX into PHP and call it PHPX. And then run it with the help of WebAssembly. This is kind of crazy, of course, you know. Who in the right state of the mind will do that? And I used to think for 3 years. Then the AI kind of came, and I realized one very interesting thing, that AI is kind of good with JSX. It generated in a very, very good way. And I can very easily tell it, OK, so now do it exactly the same, but in PHP. And it kind of works. I didn't write any line of this, you know. It's an abomination, of course. But, you know, it was a nice way to try it. So I have a functional demo, which is still not for the download, but I will do it. So if you're really interested how can be this run on the web, have a little demo there. And I will provide a source code in the upcoming weeks. So it's a just interesting technical experience and how far you can actually take the WebAssembly. Or maybe we should reconsider again the transpilation, you know, and we should use the transpilation for some DOM-heavy tasks, something which is changing the things in the HTML very often, and simply use the WebAssembly for the rest. If you have good tooling, can work, you know. Again, another crazy idea. But there was actually a proposal on ECMAScript technical committee, and the part of the proposal was, OK, let's split JavaScript into the two parts. JS0, which will be simplified for the runtime engines. Did you remind you of anything, like asm.js? And the second part will be JS Sugar, which will be feature-rich and compile-supported version, our regular JavaScript. And last visit to Japan. What did happen, actually? There is a plan to create another tunnel on the exact same place. Don't ask me why. It's a Japan, you know. But there is always something which is running in the cycles, and people are trying new and new solutions. So a quick recap. Definitely, WebAssembly is something which is more an infrastructure thing. It's not a silver bullet. It's something which can do some invisible heavy lifting. It's not something which you will show on some fancy demos, or at least it's now. Back in the days, of course, when they tried to sell the technology, it was kind of common, you know. But again, if I use the metaphor with second tunnel, nobody wants to go and do an expedition in the second tunnel. You know, there is virtually nothing to show you. If you go there by the train, there will be a darkness. That's it, you know. But back to WebAssembly. It's definitely breaking the limits in some parts. So if you, for example, have some compression algorithm, the version in JavaScript will be slower than version in the WebAssembly. Definitely, you can optimize this more in the WebAssembly. So it's still something which kind of complements the JavaScript. It's not a replacement. But of course, this is up to us. There always can be someone who will try to bend it. And I guarantee you that there will be someone. At least I actually bend it, you know. So there's always the way. It's something which is more suited for some CPU-heavy stuff. I already mentioned compression. Also, it's good when you really want, if you have some legacy solution and you really quickly want to show it to someone, this can be a way. It's good for the demos. This is probably something which I don't have it here, but it's a very, very nice thing. I already mentioned that sandboxes, which allows you to run a PHP code. Nice thing, you know. For some performance sensitive thing, but this is a CPU-heavy task. Or we can really try it. We can really try the WebAssembly without the web. Let's name it another assembly, of course, because the name assembly is already taken, you know. And it will be extremely ironical if it actually found out the place outside the web. And the truth is that we actually in our company consider to use the WebAssembly, but it was really on the back end because we need to run the code from the end users, and we never can trust that code. And we were kind of thinking about that, and maybe we will build a proper solution on that. So the end question, which I cannot answer at this question at this moment, because there is still time for that. The question is if the fate of WebAssembly will be actually same as the fate of second tunnel, just an infrastructure thing, which you will use sometimes, but still it will be an important hidden part of the web. Okay, and that's everything from my part. Thank you for your attention. So if there are any questions now. Okay. Oh, that's a good question. The openness of the web and the role of WebAssembly. Because when you think about it, and I will again start with a personal story. When I was learning the JavaScript almost 20 years ago, I started by reading the JavaScript on the other websites. Yeah, it was the easy way. Back then, the things was not so minified and things like that. So you can very easily learn or find out how these things were working. You cannot do this with WebAssembly. It's distributed in the binary form, and even with that, it's just a set of instructions, and you cannot grasp what is actually happening there. So yeah, to a degree, this can have an impact on the openness of the web, and especially on that early glorious hackers days and the beginning. When you really can, if you're interested how something works, you just show the source and you kind of get it. With WebAssembly, this is hard. So if that answers your question, thank you. Okay, so another question? You got me. And I was doing rehearsal. I was thinking, okay, maybe someone will ask about the Silverlight. And I prepared an answer for that. And the answer was, nobody cares about the Silverlight. Nobody ever cares about Silverlight. So I know it's little brush, but it was like that. For me, it seems that almost everybody was ignoring that, fortunately. But still, there was at least one very positive thing about the Silverlight, and that was, and I'm not so sure if I pronounce it correctly, XAML markup language, which was behind that. It was actually a good idea, but web didn't choose it, And again, it was a proprietary plugin, was done by the Microsoft, was supported only on the Windows, but I know that back then there was also an attempt from the Mono, some Moon Monkey or something like that, but still, it has definitely, again, a feeling of ActiveX, at least from my point of view. So thank you for the question. Okay, so I will be here. If you have any question, I will be open to answer it. So thank you again.